Hello, welcome back. This is Samuel Ambrose Onen. I'm just trying to give you a brief overview of the model that I came up with to solve computational and you know and algorithmic problems. The model is all about the conceptual and contextual understanding of the world computational problems and algorithm to solve them. So I came up with something very small. It may look like it is mathematical, but in essence, yeah, it's straightforward. As a computer science guy, I know you might have had some background before in mathematics, but if you haven't had any background, don't worry. This is something very easy to master. So I came up with a model that we have something like a problem space, and then we have a solution space. And the problem space contain A as our problem, and the solution space contain B as the expected solution or the expected output. And I model this A as the problem because problem can start from a point and end up at a point. So I model this problem to be like vectors, some vectors in the space, because problems scale up with time. And then there will be some solution. Of course, alongside the vectors, we have some solution. So there will be some solution to move us from A to B. This is the expected output. For example, as a business owner or stakeholder, you may want to do something. You may want to perhaps solve some problem in order to make money. So the thing that you want to solve is the what aspect of what you want of the solution is the what. And you want to do that thing to make money. So that will be the reason, and that is the why aspect of it. Why aspect of it. Now, the problems may exist there, and you may know the problem already, but the problem is you don't know how to get from the problem to the solution of what you want to do to give you a very good reason or make the reason meaningful for you to make a lot of money. So the problem is also about what, and then how to get from the problem to the solution is about how. That is where we need algorithm, my friend. This is where we come in to provide solutions to the problems from different perspectives using different algorithm techniques, and also we try to make sure that our stakeholders are happy. So we have this expected output. So the solution will be, I mean, the the how will be the linear combination of the problems A and the solution, the X. This is the final solution because for any problem that exists, there must be a solution for it. So this is the meaning. And then that solution must contain the expected output because when a stakeholder gives you requirements or what they want to solve, and those will be the expected output, and that is represented by this B. So when you solve the problem A, it must be commensurate with the expected output. So if you don't meet the expectation of the stakeholders in any software development or software product, that software system will be rendered useless. That's why B is very important. So now the overall solution, which is neo, will be the expected output as a product of the inverse of A. This A inverse is the transformation that we are going to make in the problem in order to get the solution. And this B is the measurement of this problem to see whether, of the solution, to see whether the solution has met the expected solution that the stakeholders would like us to provide by applying the methods here. So the what here and the what and the why there, they are all different types of knowledge. That's why knowledge is very important in algorithm design and implementation. So knowledge can be defined as the fact or the information, something that you know through experience. The information or the facts known or gained through some kind of experience. And the experience could be by learning or by trial and error, you name it. Could be by doing a lot of things, but going through that experience will give you some knowledge of what you're doing, so that next time if the same thing comes again, you know how to do it because you got the data bank for it already. So the what and why, they all fall under different kind of knowledge. But the knowledge that we need for algorithm is the how, because we want to know how to do something. So what is not enough, why is not enough, but we need how to complete what and why. So the knowledge that describe what is called declarative knowledge, yeah, declarative knowledge, because we are declaring what to do. But the why is comparative, comparative knowledge, comparative knowledge, because it compares, why, which, where, when, they are all under comparative knowledge, and then this giant how is our imperative knowledge, imperative knowledge, which is required for algorithm design, development, and implementation. So you can see inside how we have what is known as the metadata, metadata, metadata. This metadata is basically the ingredients of all this knowledge, but they are embedded inside the imperative knowledge. So, my friend, I'm going to stop here. This is basically the summary of my model, and it's all about nu equals A inverse times B. This is the contextual and conceptual model for understanding algorithm and computational problem so that we can provide solution to them. So thank you for viewing. My name is once again Samuel Ambrose Onen. I am a BSc, MSc holder of Advanced Computer Science and a reader of mathematics from one of the most prestigious universities in the world. I hope this video has been informative, and thank you for viewing. You can join me in Udemy, YouTube, and many places over the internet to learn more about my course. I hope you will be able to gain something from it. Thank you.